This video, we're going to talk about the quadratic formula that everybody talks about, but what I want to start with is where it came from. And I want you to know that you have the skills to come up with it from scratch as well. Now, normally when I have a class, I have the class tell me what to do. I stand in front of the class and they tell me what the steps are. So I want you to try to kind of think of this as if you're in a class and try to guess what the step is before I tell you what the step is. So I should be your confirmation as opposed to leading you through this. So in the previous video, we learned how to complete the square and then square root both sides and then get an answer, right? Remember the plus or minus when you square root both sides? So I want you, and we had a list of steps, right? There was a specific set of steps that you used to complete the square smoothly and quickly. And I'm going to give you the first one. Okay. And the first step has to have a lead coefficient of a 1, right? Now, we are not going to complete the square on something that's got 2s and 3s and 4s and 5s or whatever in there. We're going to complete the square on something that's got an A, a B, and a C. All right, so if I need a lead coefficient of a 1 and I have an A could be a 1, okay? A could be a 3 or 3/4 or a -2. How do I get a 1 if I just have some unknown number A? How do you get 1 from A? Did you come up with a step? Well, hopefully it was if I divide it by itself, I would get a 1. And that's only legal if you divide everybody else, right? So I'd have x squared plus b over a x plus c over a, and 0 over anything is 0. Do you remember the next step? So when I pause, you're supposed to be telling yourself what the next step is. Okay, so hopefully, because I know you know that process, you move the constant to the other side. And the constant is something that doesn't have an x in it. And if you're, this is like, okay, I don't know completing the square. That's the previous video. There will be a link to it down at the bottom. And then you leave an empty space. That's your workspace. And you always take what? You take half of this middle coefficient, the one that multiplies the x. And you say, okay, half of b over a is b over 2a, right? And you put that here and square it and do what? What you add to one side, you do to the other side. So every one of those pauses is a chance for you to think about what you would say. Now you've completed the square, but you haven't showed it to me yet. So I want to see this binomial square. So what are you going to bring down? Okay, you're going to bring down the x without the square. You're going to bring down this sign, whatever that first sign is, it comes down. If it was a minus, it would be a minus, but we're just using a generic plus. This is always a plus. And you bring this down without the square because here's your square out here. Now on the right side, we have kind of a mess. So we've got minus c over a plus b squared over 4a squared. So if I want to add minus c over a, because I need to kind of clean that up, don't I need a common denominator? And so I would multiply this by 4a. So I'd have minus 4ac. Looks like this, right? And I can add these together and put it right there. So I'm going to put the b squared in the front because I like the positive leading. It's kind of nice form. So I'm here. Now what do you do? So now you're going to square root both sides. And the square root cancels this part. Don't forget the plus or minus. B squared minus 4ac is a binomial, so you cannot just square root parts and pieces of a binomial. So you can't square root the b squared. But 4a squared is a monomial, and the square root of 4a squared is 2a. Then we always want to know what x is. And we already have a common denominator. All right. Now, there's lots of people, there's some teachers who sing this quadratic formula to the Pop Goes the Weasel, which I'm not going to do, but I actually looked online to see if it was there. And then I found out that they sing it to a whole bunch of other things, You'd have to go look. I'm not going to sing it to you. But remember, this came from ax squared plus bx plus c. And it has to be equal to 0. You have to have the ax squared plus bx plus c all on one side to get the proper signs. Are they positive or negative? So these are the two things that you have to memorize in order to survive with the quadratic formula. All right. So let's start with when we could have factored. Let's go through this part. And so, if you're given any way that you want to solve something, you look at this and go, oh, look, it's got a lead coefficient of a 1. What multiplies to 5? It adds to 4. And there's a video on that too. Just go through the playlist. Actually, you would need to go and find the factoring one, and then it lists all the different kinds that there are. So you would say a -5 and a +1. So x minus 5 is 0, x plus 1 is 0, x is 5, x is -1. Have you noticed that the answer that we get is the opposite sign of what you start with? So if it was negative, it becomes positive when you move it over to the other side. And if it was positive, it becomes negative when you move it over to the other side. That's going to come in handy later. So just kind of notice that. Now let's say that we didn't recognize it as factoring, or they said, I want you to solve this using the quadratic formula. So first you have to go, okay, I need a, but I have to make sure that it's equal to 0, which it is. So a is an understood 1, b is -4, c is -5. And the fastest way to memorize something is to write it down a lot of times and to say it to yourself. So it's -b plus or minus b squared minus 4ac all over 2a. Notice all of it's over 2a. So x is. The mistakes that I see most often from students is this negative right here, is independent of what b actually is. All right. So you have the negative, and b in this case is a -4. And so sometimes students miss the two negatives if b happens to be negative. And so that's a problem. Now, the other thing I see is when they square it, they think that negative is outside the square, so they leave it negative. A is 1 and C is -5. And what I'm trying to say is, all right, this is a +4. But if you had -4 squared, this would indeed be -16. But if you have -4 squared, this is +16. And this square applies to all of B. So don't forget to bring the negative with it. So this is a +16. -4 times 1 times -5 is +20 over 2. So you have 4 plus or minus the square root of 36 over 2. So this is 4 plus or minus, and the square root of 36 is 6. So you have 4 plus 6 over 2 and 4 minus 6 over 2. So you have 10 over 2 and -2 over 2. So you've got 5 and -1. Now, if you look at where we started and how long it took us. Now, granted, you can leave, a few of these steps out and do them in your head, but still in all, setting it up and getting an answer and everything, it takes longer to get the quadratic formula done. So if you can factor it, that would be faster. But some people hate factoring, and sometimes you just have to use the quadratic formula because things don't factor. For instance, if you have x squared plus 10x plus 5, And you go, I love factoring. It's fast. Let's get that done. What multiplies to 5 and adds to 10? 1 and 5 are its only factors. I don't think anything adds to 10, so it doesn't factor. But they still want a solution. So you would say, all right, quadratic formula works on anything with this quadratic in form. So where did I get the little heart? I was getting ready to drop. Okay, here we go. So A is 1, B is 10, C is 5. So X is minus, in this case, B is 10 plus or minus the square root of 10 squared minus 4 times 1 times C all over 2 times A. Now, so it's a good habit to get into with those parentheses. It'll save you some pain. So it's minus 10 plus or minus the square root of 100 minus 20 over 2. So minus 10 plus or minus the square root of 80 over 2. Now the square root of 80, it seems like it should have a square in it. Okay, so 2's in it, but 40's a little bit too big, and you can see there's a 4 in there, which is another square. So let's think. So I think 16's in there. Yep, 16 times 5 is 80, and the square root of 16 is 4, and the square root of 5 doesn't simplify. So it's negative 10 plus or minus 4 square root of 5 over 2. And now let's talk about simplification. If you had negative 10 plus or minus 3 square root of 5 over 2, 2 would go into this one, but 2 doesn't go into 3, and definitely doesn't go into the square root because that's a square root. So you cannot say it's minus 5 plus or minus 3 square root of 5 because this is still over the denominator. So you could split them apart and have this part that reduces to 5 and this part that didn't reduce, but you can't reduce it into part of the binomial and leave the other part untouched. Okay, so this one happens to have a 4 and a 10, so this is negative 5 plus or minus 2 square root of 5. And you think, I'm not buying that, and I'm only going to show you this once so that you can see it. Because remember, what we were trying to do was to factor. And you remember how I said whatever the sign was, we changed it to put it back in? So what I'm going to do is, let's check this. So I'm going to change the sign by putting a negative in there. And we'll spend in college algebra a nice little section of time doing this, putting it back in and taking it out, but later, much later. All right, so these would be my two potential factors. So this would be x plus 5 minus 2 square root of 5, and x plus 5 plus 2 square root of 5. And I don't know that I'm buying that. So I'm going to stick this in one of my favorites, which is this vertical method, and check. So 2 times 2 is 4, and it's negative. And the square root of 5 times the square root of 5 is the square root of 5 squared. And then you have plus 10 square root of 5, because you multiply here, multiply up, multiply over, multiply far over, in case you haven't seen this method recently. Okay, and then you would have 2 square root of 5 x. And then you skip a spot, and you move over to this next spot both ways, and you're doing it like elementary school. 5 times negative 2 square root of 5 here is negative 10 square root of 5. 5 times 5 is 25. 5 times x is 5x. And then you skip another spot, and you take this one times everybody, and skip another spot down here. And you have minus 2 square root of 5x plus 5x squared. And so this is minus 4 times 5. These cancel. These cancel. This is 10x. This is x squared. So you have x squared plus 10x plus 25 minus 20. So x squared plus 10x plus 5. That was where we started. See? Okay. Now what this boils down to is it kind of goes like this. What multiplies to 5 and adds to 10? Oh, -5 plus or minus 2 square root of 5. I don't think so. Okay, so that would not have occurred to me. All right, but if you can think like that, and if you are good at thinking about square roots, and these are conjugates of each other, that might have occurred to you that that would multiply to 5 and add to 10, but it would not have occurred to me. So I just wanted to show you that it does do that, even though, right now we're not thinking about it. Now, I did want to point out one thing. Okay, see right here, right at this moment, we had the square root of 36, which is a perfect square. So we ended up with a nice integer value from that. This thing right here is called the discriminant, the part that's underneath the square root. We have another video coming right up on that. But the discriminant tells you what kind of answers you're going to get before you actually solve it all the way out. Likewise here, I did not have a nice clean square. I had something with a square contained in it. So I still had an irrational square root of 5 left. All right. So you can tell from the discriminant what kinds of answers you're going to get, which sometimes, especially in future classes, turns out to be handy. So what if you have 2x squared plus 5x equals 1? A is definitely 2. B is definitely 5. But the 1 actually needs to be over here. It has to be equal to 0. So the 1 is actually a negative 1. So be sure that you're paying attention that it's equal to 0. Now, you know yourself. Do you actually need to write it equal to 0 in order to see the proper sign? Or can you look at it and go, oh, this needs to move over to the other side. It'd be negative. That's up to you and how comfortable you are with your skill set. So that's totally up to you. All right. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So x is minus b is 5 plus or minus the square root of 5 squared minus 4 times a times c all over 2 times a. So it's minus 5 plus or minus, now this is 25 plus 8, so this is the square root of 33 over 4. And this doesn't reduce at all, okay? 4 doesn't go into anything up there. Now, if this had been 32 right here, it still would not have gone into that directly because you can't cancel into a square root. You would have had to get the square root out and then reduce. All right, so some computer systems want you to say this is minus 5/4 plus or minus the square root of 33/4. I'll leave that up to how your teacher wants it done and how your computer system wants it done. Now, can you check these? Yes, you can. You can take this and take this, and if you're good with your calculator, you can plug this up there into x, and you'll find out that that's equal to 1, okay? But that's up to you. Otherwise, what you could do is go, let me just try 1. Square root of 33 over 4 is give or take 0.18614. And if you take that and plug it into the original one, and ask yourself, does that turn out to be equal to 1? You would get 0.999996 is equal to 1, which is really close to 1. Now, the reason that it's not exactly 1 is because this number right here goes on forever. It's irrational. And so you need to put in some more decimals to get even closer to 1, but it's saying, okay, you round it off, and so I've got a little bit of round off error. Now, let's try another one. Let's try 9x squared plus 2 is equal to 0. And you go, well, it's equal to 0, but I'm thinking I'm missing a piece. And that's okay. Okay, as long as you've got this square, everything else can be 0. Otherwise, if you didn't have a square, if you had 0x squared plus 3x plus 2, this is linear, and you would just go 3x is equal to negative 2, all right? So as long as you've got a square, that's what makes it quadratic. So a is 9, b is 0, and c is 2. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So x is minus 0 plus or minus square root of 0 squared minus 4 times a times c all over 2 times a. So you have nothing in the front plus or minus the square root of negative 72 over 18. Now, here we go. So you go, well, let's talk about the square root of 72, and it's negative. So is there a square hidden in 72? Yeah, 36 is in there. So you've got the square root of 36, you've got a negative 1, and you've got a 2. That makes negative 72. So the square root of 36 is 6. The square root of a negative 1 is an I. And by definition, right, the square root of negative 1 is I. And the square root of 2 is the square root of 2. So this is plus or minus 6I square root of 2 over 18. And that reduces to plus or minus I square root of 2 over 3. And some people will put plus or minus square root of 2 over 3I. It's totally up to what the computer system wants you to do and what format your teacher wants. Okay? Notice that this was imaginary because I had a negative number in here. So if the discriminant turns out to be negative, you know you're going to get imaginary numbers. All right, let's try one that's a little different. What if you have 1/2 y squared minus 2y plus 5/2 is equal to 0? And you go, well, it's equal to 0, so that makes me feel good. A is 1/2, B is negative 2. Whoops, how about a negative 2? C is 5/2. One more time. X equals minus b plus or minus square root b squared minus 4ac all over 2a. So x is minus 2 plus or minus 2 squared minus 4 times a times c all over 2 times a. Now, I know that most people, I'd say the vast majority of people, you know, when they see a fraction, they go, their eyes start squinting up and they're kind of like, oh, man. Okay, I happened to say that one time in a class when I was first starting teaching, and I said, yeah, I don't like fractions either, and my boss chewed me out. Okay, you should tell students you don't like fractions. And I was going, well, I'd rather do one without fractions. Okay, so here we go. Let's see if we can do anything with this. Now, once you have a pattern and you have a system on how to solve something, you may not care for fractions, but you just treat them like they are a number and do what you would have done if they weren't a fraction. Okay, so you have plus 2, plus or minus the square root. This is 4, right? A minus, right, times not a times a positive, still going to be minus. Okay, these two 2's right here make 4 on the bottom, times this 4 are going to cancel and leave you 5 all over, and 2 times 1/2 is 1. So I'm kind of liking this problem now. Okay, I didn't like it 5 seconds ago, but I really like it now. So it's 2 plus or minus the square root of negative 1 over 1, which, okay, I don't need that. So this is 2 plus or minus I. So just like up here, once I had this negative underneath the square root, I know I'm going to get negative numbers. All right, so this is what x is. And then one more. I promise this is the last one. All right, x is minus b plus or minus square root of b squared minus 4ac all over 2a. Like I said, if you write this down every time you do a problem, you will memorize it. Okay, equals, whoops, I didn't need to do my a's. A is 1, b is 4, c is 4. So I have minus 4 plus or minus 4 squared minus 4 times a times c all over 2 times a. So this is minus 4 plus or minus 16 minus 16. Oh, that's different. Over 2. So this is minus 4 plus or minus the square root of 0 over 2. Well, the square root of 0 is 0, so you have minus 4 over 2, which is minus 2. So this one has one answer. It's actually there twice. Okay, so let me show you what I mean by it's actually there twice. X squared plus 4x plus 4. Because when you get a nice integer answer like down here, that means you could have factored it. And what that does to me, I go, man, I missed it. Okay, I missed the factoring. I like factoring. So what multiplies to 4 and adds to 4? 2 and 2. So x plus 2 times x plus 2 is 0. X plus 2 is 0, or x plus 2 is 0, so x is minus 2, or x is minus 2. So you get the same answer twice. Now, in the quadratic formula, it only shows up once. Well, kind of. It's actually minus 4 plus 0 over 2 and minus 4 minus 0 over 2. But, you know, you just get one answer, apparently. Okay. But this is actually there twice. They call it a double root. Okay, and when you start graphing in college algebra, they'll hopefully talk about double roots. Okay, because there's something kind of cute about them. All right, when you graph them. So I hope this helps with the quadratic formula. In the next video, we're going to spend a little bit more detail on what that means about the discriminant, but keep in mind that the discriminant, and what I'm saying is this discriminant. Okay, the discriminant tells you what kind of answers you're going to get. Are you going to get integer answers? Are you going to get imaginary answers? Are you going to get ones with square roots left in them? All right, so we're going to talk about that really briefly in the next video. Don't forget that in the description below, there's a link to practice problems, and after the practice problems page, there's all the solutions, you know, to them so that you can practice. Okay, and then there'll be links to other videos, and please like and subscribe. You know, like this video if you like it, and subscribe to this so you can get updates.